Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the periodic table, and this basically is going to be a broader discussion on the concept of a comparative study of S and P block elements. In our introductory videos, I've discussed on various categories or categorization of the periodic table into various range of elements. And this, of course, is dependent on their various physical and chemical properties. Now, in this case, I mentioned on the various historical development and contextualize some of the input that was done by some of the scientists like Dmitry Mendeleev, John Newlands, and of course, Lothamer and other scientists in trying to develop the present version of the periodic table. And of course, this is going to be one of the, concepts that we are going to rely on in trying to see the comparison between various elements down the groups and across the periods as we're going to see. Now, in this particular discussion, I'm going to limit myself to the discussion on the concept of group 1 elements. And this, of course, are going to constitute elements ranging from hydrogen to francium, this lower part. Now, this rough sketch of the periodic table, I've just given it in terms of color codes, and I hope it's legible from your other end. So basically, I'm just going to use it for illustration of these specific groups. Now, in this case, the group 1 elements is this specific column which has been given in terms of green. So this is ranging from lithium, sodium, potassium, rubidium, cesium, and francium. And of course, hydrogen has been categorized into these specific groups, but we're going to look at some of its unique properties. Now, in this case, I'm going to follow a specific format in trying to discuss this comparative study of these specific elements for the first, second, and the subsequent groups, whereby I'm going to look at basically their specific aspect in terms of abundancy, their physical properties, chemical properties, some of their uses, and a summary of their reactions. And of course, we are going to look at some of the compounds which are going to be formed, particularly for group 1 elements. We shall look at the concept of carbonates and some of the oxides which are going to be relevant in our day-to-day applications. So therefore, we are going to look at the following aspects in that summary form. Now, under their physical properties, which, or perhaps in terms of their specific location in the periodic table, of course, I've indicated in that specific column for green. And then we shall look at their atomic sizes. So I'm going to give a summary of what we shall basically be relying on. We shall look at their unique sizes. So this is basically going to be across the periods and down the groups. And that's going to give us a specific trend of which we are going to follow in trying to analyze or compare these specific elements of group 1 elements. And then we shall look at what we refer to as their relative atomic masses. Atomic masses. This is the trend of their atomic masses in comparison across and down across, of course, the periods and down the groups, as we shall look at them. So we shall as well look at what we refer to as perhaps their abundancy. And some of these elements are going to be found in their free states, but some of them are going to be found in terms of combined, of course, states in terms of perhaps compounds. And we shall as well look at their electrode potential. And this is going to assist us analyze the various trends of these specific elements in terms of the particulars which are, of course, mentioned on the board. And then I've said that basically we shall look at their physical properties. And then we're going to perhaps lastly but not least look at some of their or what we call reactions. I've mentioned about the carbonates and oxides, so we shall look at their reactions in general, and then lastly we shall look at some of their uses in our day-to-day applications as I've mentioned. Now in this case, I'm going to start looking at these specific elements in terms of the atomic sizes. And in this case, for group 1 elements, we're going to witness an increase in atomic sizes down the group. And this is going to be due to increase in the number of energy levels. Now, I mentioned that basically we're going to give the periodic table in terms of groups which are going to stretch across, of course, groups which are going to be columns, and then we shall have periods which are going to be in terms of rows. Now, in this case, I'm just going to give an illustration for this, but there's a specific trend which we are going to witness for atomic sizes, which are going to increase down the group, and this is going to be due, or this is going to be experienced due to increase in the number of energy levels, and therefore that's going to dictate that the size of the atomic sizes are going to increase. Now, in one of our videos, I mentioned that in trying to analyze an hydrogen-like atom, we have said that we can give the size of this is specific, of course, radius for the hydrogen-like species, which we had given in terms of 0.529 angstroms. And of course, for the hydrogen-like species, this was an evaluation which we have done from a specific discussion. Now, I'm going to give a tabular form of figures which is going to assist us compare the atomic sizes of group 1 elements, and that's going to be assisting us to get more elaboration on that. Now, we're going to see that, as I've said, hydrogen is going to be categorized as one of the group 1 elements, but it's going to display unique characteristics, especially in its reactions, whereby we're going to see that for these elements to be stable during chemical reactions, they're going to achieve what we call the octet state. Now, in this particular octet state is a stable state whereby elements are going to, especially for hydrogen and helium, they are going to attain a state of 2, whereby other elements are going to have, of course, octet. Oct, this is a prefix for 8. So the octet state is going to be a configuration that is going to see that the valence shell is assuming or getting 8 electrons in the outermost energy level, and therefore making it to be stable. Now, this is witnessed especially for the noble elements, and therefore for elements to obtain the octet states, they are going to be involved in some chemical reactions. And of course, we're going to see that for hydrogen, in case instead of losing its single electron, that is going to be, of course, taking part in the chemical reaction, or taking part in combination with other, of course, elements, it's going to attract electrons rather than lose electrons, and therefore it's going to form molecular compounds by a formation of what we refer to as covalent bonds. So therefore, I'm also going to give examples of these specific reactions or combinations, which are going to assist us, of course, to describe some of the properties of hydrogen. In this case, of course, majority of these elements of group 1, which of course basically range from sodium, lithium, potassium. So these are sodium, lithium, potassium, and they talked about this is so there was francium, and of course I mentioned hydrogen. So going in this specific order, we are going to see that some of the elements, majority of these elements were discovered in the 19th century, and some of them are going to be shown to show solubility in water. And of course, their compounds are going to display various properties, especially they are going to form chlorides, carbonates, sulfates, which are going to be obtained from some of the combined elements, like their natural primes. Now, in this case, some elements like this lower section, like rubidium and cesium, which of course we had mentioned, these elements are going to be obtained from the product during the process of the lithium ore. So the lithium ore is going to be producing some of these, of course, elements which we are going to see in our discussion on the concept of reaction, which I've mentioned. Now, basically, this is going to be a summary form of what we're going to deal with. And of course, we're going to look at specific examples, especially on the concept of reactions. And of course, I shall give a display of the comparison for these various forms of atomic sizes, ionic sizes, abundance, and perhaps electrode potential, and the relative atomic masses of various elements as we're going to go by. So this was an introductory part of the video. Kindly check our description boxes for various links of other similar videos which are going to assist us understand this specific concept. So that is it for now, guys. By God bless you. Catch us in our next video.